Welcome to the IPv6 Buzz, where we dare to dive into the 128-bit address space wormhole. I'm Ed Worley.
And I'm Scott Hogue. On the show, we discuss all things IPv6, strategy, design, deployment, and operations.
And I'm Tom Coffeen. We've spent 20 plus years working with the IPv6 protocol. We run a consulting firm where we get IPv6 working for our customers.
And we're here to share some lessons learned and how to avoid common mistakes. We're glad you joined us today. We're going to be talking about sort of 2024 and what we think are going to be some thoughts and interesting things to sort of track and some industry updates, because we felt like there was some interesting stuff that came out recently and we wanted to just talk through those really quickly. So I think the most interesting one that I saw just in terms of sort of IETF activity was Eric Finke released a website, a 6724 website for folks to go and check out, which I thought was really, really cool. And if you are not a follower or a listener of the show on a regular basis, I guess we should explain what 6724 is really quickly, which is basically an RFC that discusses IPv6 sort of source destination address selection process and what goes on with making that a reality, and how every host operating system and every device on a network actually makes the decision about how to source something from one address to get to a particular destination address. And it's actually relatively hard and confusing to figure this out. Mainly because IPv6 can have multiple, global unicast addresses, link local addresses, and obviously ULA addresses, and you're trying to figure out which one's going to source to what destination, and trying to figure that out is not easy. So Eric actually made a site that sort of allows you to source from a particular address to a destination address and what that looks like. It's very, very cool.
Well, and then V4 is a part of that too, right? Because you may or may not have an IPv6 only endpoint that you're running from that you might want to test from. Chances are there's probably some V4 hanging out there as well, and that gets into the mix in terms of which address gets selected and used. So,
yes, that's accurate. And he's kind enough to include in the drop-down list what behavior you want. So you can do 6724. You can use the older RFC that was an update. 6724 was an update to RFC 3484. And then he's got the current Linux 5.15 implementation. And then he has the current draft that Nick and some others are working on for 6724 for the update.
Nick Bralia.
Yeah. So all of those are covered in there. You sort of pick which one you want to see, and then you can source for the appropriate sort of scoping that you want to do. Longest prefix match. Do you want to prefer the smaller scope, prefer the higher precedence? There's all these sorts of things that you can go through, and it will help you figure out the prefix, the precedence, and the label. And
that's tremendously helpful, because if you've had to try to do this just perusing through the RFC to look at the prefix policy table, compare it to what you're trying to determine, what will get selected and how. This will be an incredibly time-saving tool to get you to that point where you figure out what's going on a lot faster than just trying to do it on the back of the envelope, so to speak.
Yeah, it's pretty cool, and he provides a link to the code and a GitHub repo. Unfortunately, that's V4 only for GitHub still, but he does provide the code that he used to write this particular page. So if you need it for any particular reason, you can go borrow his code to figure out how to do this if you need to, run it for yourself for any given reason. It's very cool and very, very useful for those of us that are stuck in situations where you're dealing with maybe ULA plus global unicast or multiple global unicast prefixes and trying to figure out what's going on for any given use case scenario, or what potentially could go on and what pitfalls you might run into trying to set things up in a particular way. And
for the source address, you'll put in two addresses, and you can try putting in a ULA address, an FD address, and then convince yourself that it's less preferred for a reason. Put in two source addresses, put in a global unicast destination, and you'll see that the ULA address is not used.
Right. Yeah. And I think it's important for folks that are trying to, sometimes this is a very confusing point for other teams that may not be networking folks. So sometimes this is a useful tool to walk other people through and explain why maybe ULA is not a great idea in terms of what they may want to be trying to solve for in their
Yes.
particular environment. And so you can actually demonstrate, like, actually, you're not going to get the behavior you want. And here, let me show you. And I can show you how it's going to operate in the current RFC, what's being proposed in the draft RFC, how this is all being addressed. So you can work your way through each one of those use cases. And it includes IPv4 because IPv4 is actually a defined IPv4 compatible address space that's actually part of the policy table. So I think that's an important point, is understanding whether V6 or V4 is being chosen. This RFC impacts both V4 and V6. And I think a lot of people don't necessarily understand that. So
yeah, V4 mapped is precedence of 35. V4 compatible is deprecated.
right. Yeah, sorry.
Okay. It's confusing because they look identical except for one has some FF in a certain hexstat.
We should probably add that if you're one of those strange individuals that, as a part of like the outcome of this exercise is that you just decide that the thing to do is to modify your prefix policy table, then this website probably will ultimately not be very useful for you. And we've encountered a couple of those folks in the wild. They're hardy souls that have a lot more of a sense of adventure than I do. But going in and tweaking the prefix policy table to I don't know, make ULA useful as an example. Not my cup of tea, but your mileage may vary.
Yeah, when you first think or you first recognize that there's this table inside your host OS, as engineers, we want to control it. Or if you're a security analyst, you want to harden it somehow. And so you want to control it or configure it or edit or remove entries to prevent certain addresses from being used. But then when you remove those entries from the prefix policy table, then they become active, or they're treated like a higher precedence by accident.
Mm-hmm.
And then they become reactivated when they're meant to have a low precedence and a high label. They're meant to be put at the bottom of the list for a reason. And when you remove them, then they pop up to the top of the list.
They fit in the default category. Mm-hmm. They get rolled up into default. So they become precedence 40 and label 1, and they're off to the race.
Yeah. When you think you're hardening it, you're activating things that were meant to be, prevented.
Yeah. They're at the bottom of the list for a reason.
Yeah.
Yeah.
Yeah. Because we don't use them anymore and we don't want to use them, but we want to call them out specifically. Yeah, this is one of the problems. I would say definitely this is something we demonstrate in like labs to sort of show like how you can mess everything up on a host operating system. But like both of you mentioned, it wouldn't be something that you would actually change in any active way.
No,
at least I don't think you should.
No, at the bottom there should be a little entry, semicolon. There be dragons.
Yeah, exactly. Here there be dragons.
Here there be dragons.
Yeah, because it's you can definitely get yourself in a lot of trouble. And even trying to, I've noticed some interesting things with Windows, depending on which Windows operating system you're running, whether you're running, this has been in place early on since Vista actually to be able to modify all of this. And depending on what operating system you're on and what version, you actually can't restore the prefix policy table to the previous version of what was originally published. So you have to actually go and like do a full recovery in order to be able to get 6724 to populate the way you want. Because it's a connector to a pre-built stage and a registry key and not just a file. So you can't just slam a file and like replace it in order to make that happen. And there's certain interesting things about how ULA is actually interpreted and what you can input in that may cause issues. Most of those have been fixed, but if you have older OSs for any given reason, you decide to modify ULA, you'll actually notice that you can't actually restore like FC00:/7 in the same way that it was displayed in the original table, which is a really oddball thing. So it was just one of the things that I ran into several times when building out labs, that you just notice these oddball sort of strange corner cases. It's not like you can't build the exact same entry, but you just end up building like, FC and FD in order to sort of get the same address space in there.
Mm-hmm.
It's just a weird side effect.
Yeah. But hats off to Eric. Thanks for building this website.
Yeah,
cool stuff.
Very cool. For sure. I don't know what else did we want to sort of bring to people's attention. I think there's been a heck of a lot of feature releases, or at least public statements that I've seen coming out of AWS in regards to IPv6 support. So it looks like they're really picking up the effort to get more and more IPv6 as like a, I don't know if it's a first class citizen, equal footing with IPv4 in many cases. But I guess that's you know, take all of that with the sort of regular PR madness that comes out from, any of these cloud companies, right? They're going to announce every single thing that's going on. That's a new feature set of capabilities, and it looks like they're accelerating more and more V6 support. But I think you always want to sort of double check and make sure that they're actually releasing stuff that sort of solves that problem. Maybe we can talk through that really quickly. So we'll provide in the show notes some links in regards to what AWS supports for IPv6 capabilities, and they've got a nice little table in here that sort of demonstrates that. But I don't know if this table tells you everything, right, Scott?
Yeah. I mean, every month there's one or a few IPv6 features that get announced in their blogs and their IPv6 product announcements. Every couple of months, those people at AWS are working hard to add more IPv6 features to more services. There've been even just 5 or 6 just in the last 6 weeks,
Yeah.
And so, they are working to add IPv6 support to different functions. In recent months, it's been Amazon Lightsail, S3 on Outposts, IPv6 on Amazon EKS, more stuff on EKS security groups, VPCs with IPv6 CIDRs, OpenSearch, Athena,
Yeah,
Global Accelerator. It's like it goes on, but every month there's been a few, and over the course of 2023, quite a few features, IPv6 features added.
Yeah, they've been just coming out and just really, putting a cadence behind it, which I think is important. And I think this maybe dovetails into the next topic we were going to talk about, but I think there's some external factors besides internal factors. There's some external factors that are driving some of their behavior about why they're releasing as much, sort of feature update capabilities for their platform, right? So it's features versus functions. So it's getting their functional capability up from a feature parity standpoint, right? So they're trying to attain as close to feature parity as they can, V4, V6, which is good. But you actually have another website that you utilize besides the Amazon website for sort of looking at what is capable in V6, V4, and dual stack for service endpoints by region, which is really this site's really cool. I'd never seen this site before, so why don't you talk us through it real quick?
Apparent X, and on Twitter or X, it's at Apparent Order is their handle, and they have a AWS IPv6.neveragain.de is a website that breaks down different functions or different regions, and then you can look at which features use V6 by default, only like 4% or 5%, IPv6 or dual stack capable, maybe 5 or 6%, and then services that still rely upon IPv4 in some way, shape, or form, and that could be like maybe 90%. 88 to 90%. And you can see which features in different regions, allow you to get away from having to pay the IPv4 tax, if you will. And you see where there's services there are many services, the vast majority of services still have IPv4 dependencies. And even if a service does allow V6 only or dual stack configuration, it doesn't come by default that way.
Right.
You still have to enable it manually in the way you configure that service.
Yeah, it's a good point. And I think, correct me if I'm wrong, but like this month or next month, the charge is supposed to kick in for V4 address space. Is that right? I think I want to say it's February or March that they're going to be turning the billing on for that.
Yeah, there's a lot of notes in the news about that, and the hundreds of millions of dollars in revenue that Amazon's going to be generating off of IPv4.
Yeah.
How that's impactful for folks that are using the cloud. They're already deployed into the cloud, and whether or not they have a path to the services we just talked about. The sort of checkerboard of available where v6 is available. Can you transition over with your particular cloud architecture that you're using, the operations that you're using today, to take advantage of v6 and maybe avoid some of those costs? That's maybe a little too early to say, I think, for most folks, but there's definitely some incentive there, right, to move away from v4.
Yeah, the change took effect February 1st, 2024.
Okay, just happened.
And the change was that before, if you were using a public v4 address, an Amazon provided v4 address or an elastic IP, as long as it was associated with a resource in your VPC or being used with site-to-site VPN or global accelerator, there was no charge. And now it's it's half a cent per hour. It's the new pricing. It went into effect February 1st.
Yeah, so it's not onerous, I don't think, in total for the year, right? I mean, it's like
$43.80 a year.
Yeah. So it's not earth-shattering in terms of dollars. I mean, if you're running huge resources in AWS, it could be, right? You're running thousands and thousands of nodes that have, are making use of Amazon's public IPv4 address space, and they could be financially impactful.
Yeah, you could have AWS account that has 100 elastic IPs, and now it's $4,000 more.
Yeah.
Pay this year times however many customers about that size.
Yeah. Amazon's going to make lots of money with this.
Yeah.
It's sort of free money. So
if Amazon can buy a public v4 address on the open transfer market for less than $43, they can rent it to you for the cost of $43 a year. And at the end of that year, AWS still owns the address. They can rent it out again for another year, for another $43. So, yeah.
It's opportunity on top of opportunity.
Yeah. So if you can buy IPv4 addresses on the public transfer market for less than $43 a year, you should.
Yeah, and then you can, for those that don't know, you can actually port or do what's called bring your own address. So you can actually bring your address space over to AWS. You could pick up an address space specifically for that purpose, and then just allow your services to use that address space. And you shouldn't be charged. You'll be charged for the porting, I think, but you don't get charged for the actual use of the address.
Yeah, the ongoing
if you're using
use.
it
You still pay for egress.
Yeah, that's just packets in, packets out, right? So
yeah, you'd pay for that, but you wouldn't pay the half a cent per hour.
Right. Yeah. So there are options depending on what you want to do, and that might make more and more sense for other organizations to do something like that in terms of what's going on. But it's definitely, I guess this is a good way to talk about the next point, which is sort of Scott, you've written an article on sort of global ripple effects, and on the InfoBlocks IPv6 Center of Excellence. We'll put a link in the show notes for that too. And there's sort of 2 points around this, as sort of AWS moving more and more towards v6 and charging for v4 is definitely like an industry trend behavior that is going to push more folks towards IPv6 and what's going to happen in terms of what that looks like. Obviously, Microsoft and Azure is going to have similar sort of impacts. And I think a lot of this comes from maybe the US federal government's global adoption initiative around v6 and saying like, hey, we need to get v6 operating. We want to run in public cloud. Where's our support for IPv6 in the public cloud? And so I think part of AWS's behavior is partially being driven by the cadence of that requirement and needing to get, their US Gov East and US Gov West IPv6 capabilities sort of, level set up to be able to support the US federal government in the way that's being required by all the federal agencies that are that are actively using those services, and that's going to be true for Azure and for Google too. And I guess if you're going to go through the effort of just building, two regions around that, you might as well just deploy it in all the regions that you possibly can, just to keep things consistent, right?
Mm-hmm.
Is sort of my guess about some of the behavior that's going on. I could be entirely wrong around this. It's completely speculation, but it seems to make sense to me, that would be partially driving some of the behavior that we're seeing, from these cloud operators. I don't know. Do you feel that sort of lines up with some of what you're talking about in the article in regards to what's going on in the industry overall?
Yeah, like when federal governments like the US government or China or Vietnam or the Czech Republic, makes a statement about their goal for IPv6 or V6 only, I think the industry notices, and there are flow down requirements to citizens or companies or service providers, or just an increased awareness of the importance of IPv6 and this global transition that we're all going through, and makes people realize, oh, well, if all these organizations are doing that, if AWS is moving, if cloud providers are transitioning to use IPv6, or service providers have a preference for IPv6, well, then, we should move as well. So it helps create awareness. It helps build momentum, or helps organizations build a business case for why they would move. So it helps move things along.
Well, and
Yeah.
you mentioned the Czech Republic. That was just the recent announcement, right? So they're deprecating IPv4 by 2032. Is that the date that they put in there?
Mm-hmm.
Yeah, and of course it was June 6th, 2032. June 6th, the date that's very important to us IPv6 nerds.
666.
And so harkening back to World IPv6 Day.
Mm-hmm.
But yeah, that was just recently announced, and so yeah, that ripple effect is clearly in effect.
Yeah, I think it's important for people to realize that basically they're stating they won't have any basically services available on IPv4. Now, I sort of question about there might be other entities that build like proxies in front of them to make IPv4
Right.
still accessible for them, but the Czech government themselves won't operate any services on IPv4 at all. They'll be basically providing, I don't know if their internal sites will all be required to be V6 too, but at least from what I understood from what they wrote up, is the intent is that everything will be ported over to V6, and that will be that, and that will be the standard.
Yep.
So everything will be cut over. So I that's quite remarkable. I don't think I've seen anyone else make that statement there. I think they're the first out of the gate with a statement like that, because everyone else that I've seen, they haven't put a foot down that said that V4 is actually getting shut off in this way, right? Have you guys seen anyone else that's said that?
Yeah, Vietnam
Said it? Okay.
said 100% users using IPv6. I guess maybe that didn't say they were turning off IPv4.
Yeah, this is pretty much saying they're turning off IPv4, which is they have an end of use date. They're like, yeah, it's not going to be on anymore after that date, which I find fascinating. Like I can see lots of organizations say we want to get 100% V6, but we're still going to have V4 for just backward compatibility, and it'll be hanging around as a legacy thing for like forever, right? That's just there for the purpose of dealing with anyone who happens to be still stuck on IPv4. But this is quite a different statement than that. This is basically saying like, yeah, we're shutting V4 off, and there won't be any services available on it, which is,
I guess, yeah, it's similar to the state of Washington's Policy 300,
right?
Which said they actually did have a goal of turning off and decommissioning IPv4 by December 31st, 2025.
Yeah, sort of wild.
Mm-hmm.
Get ready, Washington. You guys are first in the queue.
The IPv4 police are going to be knocking on your door soon.
Yes.
It's like, are you still running IPv4? We've detected IPv4 from this location.
Yes.
Would you come with us, please?
Well, what's fascinating is the two largest cloud providers happen to be headquartered in Washington.
That's right.
So, AWS and Microsoft being the two up there. So I don't know. They go in and the V4 police are going to grab all their existing V4 pool and say like, that's it. So it's V6 only or nothing. Maybe that's why they're running so fast. Yeah, pretty wild. Well, do you guys have any just sort of general feelings for how things are going to bake out for 2024? I think we're going to see a lot more announcements of this type, both from the cloud providers, just in the cadence of release of V6 support, sort of across the board, from all of them, from all of the public cloud services, and a lot of the SaaS companies too, because of the requirements of what they need to support. So I think the vendors and manufacturers for hardware and for software services are going to, I think we're just going to see a big uptick in just press releases about V6 support and capabilities.
Well, I got to put my IPv6 evangelist hat on firmly and say, like, as I've said every year since, I don't know, 2008, this is the year. This is IPv6 this is the year IPv6.
It's the year of IPv6 in the desktop. It's just like Citrix. So yeah, I think we are I think we're going to see more government announcement too, just in general, just because of some of the limitations and some of the geopolitical stuff that's going on today. I think there's a lot more things that are going on, and just in terms of people realizing how important networks actually are, right?
Yeah.
I think there's going to be some behavior and changes just in terms of how that plays out too. So I would definitely keep an eye on all of that, and then some of the podcasts on the rest of the Packet Pusher podcast networks have some interesting topics around what they're covering too, and I think a lot of those have a lot of dovetailing with IPv6. So you might hear a few topics cross or bleed over with some of the other shows as things move forward, because we definitely think there's going to be more activity on that side of it. I don't know. Any last minute things, you guys? I think that's it on at least the things I wanted to talk about.
So be sure and check out the show notes. We have links to the things we've just talked about here and these useful resources we've mentioned.
Yeah, and if any listeners have big plans for V6 in 2024, we definitely want to hear about it.
Yeah, that would be awesome. Well, it's great. It's great talking with you guys about this. So I keep an eye out. 2024, lots of industry updates. That's our prediction. Thanks for joining us for this episode of IPv6 Buzz. If you've got feedback or a follow-up on this topic, send us a message at packetpushers.net/FU. We'd love to hear from you and continue the conversation.
Also, on packetpushers.net, you'll find a range of deep dive technical podcasts for IT pros, including heavy networking, heavy wireless, and day 2 cloud.
There's a whole lot more on the Packet Pusher site as well, such as tutorial videos and a networking job board to help you find or fill your next great role. So whether you're deep in your career or just starting up, Packet Pushers is the place to go to grow both your skills and your personal network.
So long, and until next time, we'll see you on the IPv6 internet.
Thanks for listening to IPv6 Buzz, a podcast devoted to truth, justice, and 128 bits of address space. IPv6.